Hello again, and
hello,
welcome
Amanda.
to yet another live broadcast from QSITE 2015. We have a very qualified and formal panel. No, we're just kidding. We have, okay, can I say that again?
Yep, I was going to say thank you for joining us live.
We're still alive and still happening. So we have a very strong contingent of QSITE members here with us today, holding a variety of critical roles within QSITE, supporting teachers and making a difference to our world. How about we get you guys to introduce yourselves?
I'm Tim Stephens. I'm a teacher at Terrace and been teaching sort of the digital technologies curriculum for the past 5 years, I suppose, 5-6 years.
What do you mean sort of teaching? Do you look at analog computing in there or something?
It was sort of an ICT, and it's actually moving more into digital technologies, more into the programming.
Prior to the syllabus, I'm Peter Whitehouse, and I teach with Tim. I have the great privilege of teaching with Tim. Prior to the Digitech syllabus, the only thing we really had a hat to hang our hat on was was the ICT as a general capability, and that's a very broad puddle of stuff. And when the Digitech syllabus came along, it offered some fairly pointed computer science opportunities and really played to our strengths. We suddenly thought, oh, we can do this, we can do this, we can do this, and it all starts to fit into an organised puddle of information as opposed to a very general capability. And we're quite happy to divest that general capability to other teachers and say, well, okay, we don't want to teach spreadsheets anymore because that's important but not interesting. We want to be able to use a fusion table, for example, and collect data live and analyse it and overlay it on a map, because that's way more interesting and it doesn't fit in with what business teachers need their kids to know, but it does fit somewhere, and it now fits in Digitech, which is fabulous.
Thank you, Peter. So bringing in the relevance and connectedness and computational power, real computational power.
Well, yeah, because computers make that stuff easy. Prior to doing that, you do a static infographic on a piece of card and stick it up in a science fair and bore everybody senseless. Whereas you can use live data and the power of the networks that you have to collect stuff and represent it and do cool stuff.
Interesting. Jason.
I'm Jason Zagami from Griffith University, and I try to prepare new teachers to teach this subject. And now it's good that it's actually a subject that I can prepare them for, rather than preparing them for things that they went out on the prac and came back rather upset saying, no one else is teaching this. What have you done to us? So now to be...
So will that change?
Probably not, but you know, we can live in hope now.
I think that it's looking good, but from last Friday when it's been endorsed and the Prime Minister and all that, there is a big push for the country. So I think it is an exciting time.
For me in Victoria, when we got a letter from our Minister, and it had smack in the middle on its own line, not a paragraph, its own line, and it says, we will fund teacher education for coding and building positive relationships.
And therein lies an issue, because the Digitech syllabus isn't only coding. Coding is probably the most easily accessible part of it, because there are plenty of people who've done coding in the community, and we can influence the nature of coding in the school because there are some really powerful visual tools that are really easy entry points and they're fun to use. But coding is really only one part of the Digitech syllabus, and that's a real problem because information systems, data representation, a lot of those other more pure computer science issues, as well as a whole lot of the different types of thinking, are vaguely hinted at in a lot of the container documents and supporting documents, and that's where I think most schools are going to struggle. How do I do that? I can get my head around coding. I can understand why you would need to do it, and there's a big international push towards kids need to be able to code because makers will be the inheritors of the planet. But it's not just coding makers. It's people who are competent at a broad range of different types of computer problem. And that's, I think, a real threat to successful implementation of the Digitech syllabus is how do we get practical examples of the breadth of the syllabus out to people so that they have a chance to play with it first, get comfortable with it, and then, more importantly, engage kids with it at a high level, a non-trivial level. I think that's the big challenge.
Because it's really not just about the coding skills. There's so much more involved. And I know that's one thing, Jason, you're super passionate about, is not just the following a script of how do I make this particular product, but engaging students in the whole entire cycle of creating these.
Yes, well, I certainly see coding as a skill, but it's a skill that enables the achievement of other things within the digital technologies curriculum. I actually consider coding an ICT. It's a particular capability that you need to be able to do things within the digital technologies curriculum, but it's also quite a useful capability if you're doing mathematics or geography and many of the other areas. But it doesn't actually form anything special within the actual curriculum itself. It's one of the skills that you need to be able to do all the special things and develop your thinking skills and stuff. And it's the main subject where that's developed, but it's not the preeminent purpose of the subject to teach coding. Unfortunately, though, it is a useful catchphrase and a soundbite that people can, particularly politicians, can use.
They can grasp it.
And they can spell it.
It is, and I have spoken to some of the politicians, and they do understand things in much more detail than the sound bites that they present to the media would suggest. They have certain political agendas that they have to sort of push, and coding is a nice word that gets public support. And I think we can use that. So while we do have to be careful of it, we can still use that to help achieve our wider aims, as long as we keep in mind that the subject is much more than just coding, as computer science is. And even in Australia, like, there was danger of us emphasising computer science too much. In the UK, that's their new term for the subject. But here we didn't want to just focus on computer science, because computing is actually quite a lot broader than that.
But isn't the reality of the label that the UK are using for computer science really just rebadging mainly coding?
To an extent, but their curriculum also incorporates ICT.
Okay.
But they're no longer allowed to use the word ICT.
Yep.
But while in Australia, we've got the ICT general capabilities and we've got the digital technology subject. In the UK, they've just got one subject called computing, and they're having difficulties bridging that interrelationship.
So we've been very sensible in keeping them apart. And
well, there are strengths for both approaches.
Okay.
But we've certainly got some strengths, and we have to work through that now. The confusion we have is teachers not understanding the distinction between them, and that has to be explained in whatever system you're using. Whether or not the UK system, where they've got one subject, they've got to explain the computer science aspects and what was ICT. Here we've got the ICT general capabilities, we've got the digital technologies, and we have to clarify to teachers when things are what. And often it comes down to simply the purpose of what you're doing. Sometimes you might be using a spreadsheet to do some simple graphing, and that's clearly just ICT. But you might also be using a spreadsheet to do some really complex programming, which then falls within digital technologies.
Yeah.
I've noticed that we're getting a lot clearer on the language, and that's an important part of how we want to work. We want to be clear as to what an algorithm is. And so I've noticed that the ACCE group has done really well with being able to put together some infomercials or infographics and some movies. Are we seeing for the first time some consensus between the states, what these words mean, how to use them, and how they need to be embedded in the curriculum? And is that the strength of this?
Well, I think there's always been a reasonable consensus amongst the computer education community about those terms. It's the understanding of those terms amongst the general teaching population, particularly primaries now, that's going to be confusing, because most teachers haven't heard the word algorithm before, or computational thinking, and a whole lot of the other terms that we incorporate in there.
So those how do we extend that understanding?
Well, that's part of the role of the curriculum, and it has a glossary of terms. But just as when science was first introduced into the curriculum, understanding what mitosis was, I probably don't do that primary level, but there's a whole lot of other terminology around that subject area when it was introduced that primary teachers wouldn't have had experience with.
That's what the QSITE tried to do with the Digital Champions programs, was to get people talking about this curriculum and trying to understand it and unpack it. Because some of the stuff around coding and general purpose languages and object-oriented programming, we had big discussions about that, whether you could use visual programming to do that, or do you have to use Python or some other language like that. So that helped develop the discussion, and the ICT thing as well. Because I went back to my staff and at the staff meeting, actually said, this is what ICT is and this is what digital technology is. Don't walk up to me and say, why aren't you teaching spreadsheeting or why aren't you doing a glossary in Word? What are you teaching them? I had a teacher come up and say, why aren't you doing touch typing? I'm going, well, I haven't got time for it.
I've never had that conversation.
Yeah, that's why in that staff meeting we actually said these are two distinct areas.
And there have been some interesting side effects of that discussion, in that we've had in our school primary teachers saying we want computing back into the primary, because we, through our complication of timetable for the grade 5-6, had no scheduled ICT or Digitech lessons this year. They said we want it back, and we had to have a conversation with them, and are still continuing that conversation to ask, well, what do you want back? Because I think they're actually suggesting they want the teach the kids how to do spreadsheets and Publisher and how to use a word processor, and we're not interested in doing that, because it comes back to a more important point, I guess, with the teachers, is that if they're expecting kids in a learning activity in their particular subject to use an ICT skill, then they can't presuppose that the kids just have it, because there's no such thing as a digital native in my experience. If they want them to use a skill, then they have some responsibility in making sure the kids have that skill and skilling them up in that particular area. And that is an interesting piece of ownership. So that knowledge is an interesting piece of ownership.
So let's look at the question that we have for this panel here. So what?
Well, on that issue, the implementation of the new digital technologies subject for all primary teachers will mean that they have to engage with computing now at a much deeper level, not just the ICT aspect, but actually teaching concepts related to computer science. That should help teachers gain ownership and stop relying upon specialized courses to do the ICT skills and so forth, because they can then think, okay, I've got to teach about this information about data and give students an understanding of the power of computers to do data. A spreadsheet might be a great thing to do for that. And I'll have to learn how to use spreadsheets to help me teach these digital technologies concepts.
That's a good point. And I guess it means that it does allow you to actually find the context that's relevant for the students, or allow them to generate the data and have some ownership. That's always a danger when we begin to isolate it in its own little subject, that it's acting in a bubble away from the other things. So if you were doing a multimedia or a multimodal project with an Indigenous group, you can bring on board the technologies that are relevant and are going to build on the skills that you need at that point. But so what? Are we already doing it? Or is this going to be a spur to our vaulting ambitions?
Isolated teachers have been doing really great computer science stuff for forever. Since computing was introduced into schools, but they've always done it in isolation and often in contradiction to the curriculum. Now we have a curriculum framework that allows them to justify doing those great robotic courses or computing programming courses within a set curriculum and in a developmental way, so they don't also have to start from scratch each time. That's the big power of the Australian curriculum.
Unless they're using
scratch.
So it's reducing some of that vertical silo where I don't have to assume that the primary school kids haven't seen a computer, have never logged on, and completely alien to the idea of a touchscreen device. They've actually been able to understand basic binary, some simple
And it's the
programming.
teaching of PowerPoint year after year after year, because everyone assumes that students haven't done it before. Well, we've got to do something around ICT, and let's do PowerPoint because I understand PowerPoint. And that's one of the key reasons why kids have been turned off computing for so long. And that's something we have to address, because yes, we can say that they've got a great brand new shiny subject, but students have been disengaging from computer studies, hopefully because of the reasons that I said. And that now we've got a proper developmental curriculum with lots of good content in there that's at a high level that will engage students. But that's not entirely certain. We don't know if that's really the cause and effect processes. We might be fighting a much greater battle with students disengaging from computing because of societal issues and a whole lot of other issues. I hope not. I don't think so, but we don't know for certain yet.
Stuff that I've done with my grade 8s and 7s, they've been loving it. Like the power of that, the Python and the wow factor that they get from that, the feeling like they're in control of this technology.
And that idea of I made this.
I made this. That's the ICT thing, where it's not just a user, you're actually.
But we don't really know what it's going to be like though once they've done 11 years of that.
Yes.
Well,
with any luck, that provides an imperative for continual refinement of what we're doing, continual pressure to improve the tools to create new experiences. When you think back to something as complex as data overlay on a map live. 5 years ago, you couldn't do that.
No.
Now you can get primary kids to do it.
Yeah.
When you think about app development, for example, that used to be really, 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 really hard and only done by people who knew a lot about programming. And now there are tools that make that trivial.
There is, but that also causes some problems because if a grade 5 teacher says, okay, great, I could do this app development stuff and this mapping, I'll do it all in year 5. And all the good stuff is done by year 5. What then happens in the final years? They don't want them to have to keep repeating that and then getting bored of it.
But the beauty and richness of the subject means that there are many layers to all of these things. So you can actually start engaging at much higher levels and start thinking in abstract ways and dealing with really big problems and in socially interconnected ways. So it opens the door to a puddle of computer science that ICT never had access to.
In Melbourne, I've got a class, Year 10 game programming, and we've been looking at traffic modelling. It's not quite game programming, but if you think of a scratch-based subject of programming, we took them to the Traffic Operations Centre where they have the various simulations of how vehicles move. They understand the issues and the control factors. We went back, and the leap ahead when they had a real-world context and some actual traffic engineers were looking over, giving feedback. And because of the nature and environment I chose, they were commenting on each other's code and not necessarily stealing, but using the solutions that each of them had. We've got traffic light systems, broadcasts, collisions avoidance models, and
so they were working as a team. You're kidding, that can't happen. Computing can't let kids do that.
Well, it's very different to week 3. We do levers, and in week 4, I introduce a variable, and then kind of working through. Now, I know that...
it's very professional when it's the presenter doing that.
No, that's not me.
That's not me. I think that the real world is such that we can expose students to problems and they can find a context that they can relate to and feel like they're participating, that the solutions that they have aren't just trivial game applications. They can see the context of interest. Some of the students are very much arts-based, and they've been building DeLoreans. They found out it was my favorite car, and so I've got a highway full of DeLoreans racing around. Others were more interested in the game, and so they're interested in the collision avoidance model, but they're drawing from their gaming experience of Counter-Strike, where things don't collide through walls and objects are aware of the existence of other objects. This is leading to the project for the next term, where we're building an autonomous vehicle using a similar programming language. This is a Hummingbird kit, and I'm extending it further. I'm excited by that. When you bring outside stakeholders in like that, they're surprised that schools aren't the way that they had learned, which were traditional subjects, that there was enough flexibility in the curriculum for me to build these things in.
But in general, we're all very experienced with those possibilities. Most teachers are not. And we need to understand now that this curriculum is going out to all primary teachers. And many of them have never done any computer programming in their lives. They are going to be very dependent upon very limited resources at the start. My big fear is that there's going to be a lot of repetition of those resources and students might be disengaged from those processes. We need to get the really good ideas that we were talking about disseminated out in a way that the general teachers can engage with and utilise in their curriculum.
Is that the role for groups like QSITE and ACCE to act as curators for these ideas and as forums?
No, QSITE and ACCE as a national body is around computer educators. We're talking a much bigger problem than just computer educators. Now it's a general education issue. As it's been endorsed and it's rolled out to all primary teachers and a large number of secondary teachers. Secondary teachers will probably define themselves possibly as computer educators, and yes, then QSITE and so forth. But for most primary teachers, unless they're specialising in that area, they're not going to recognise themselves as computer educators, even though they're doing some computer education. So it really needs to be a departmental and a systemic approach, because QSITE and ACC just don't have anywhere near the capacity to look after all, literally tens of thousands of teachers that are required to.
It's not a new problem, and change can happen. I mean, primary teachers would think of themselves as teachers of literacy and numeracy, and they're similar issues.
It is.
Cultural change takes time and resource and commitment and patience and other fun stuff.
I'm just very cautious about people putting it on to some quite small professional associations to try to address a very, very large
issue. There should be a good opportunity, but
there is, and we can certainly provide leadership in that. But we don't have the capacity to do it all. That's
so too big a department has to take the initiative in instigating the discussions engaging in the dialogue and encouraging open debate about this, because there will be tension over that change, and there may be some resistance and technology refusal, but there is good research that underpins why we need to drive this.
And we saw it with the ICT agenda. For a long time, professional associations tried to drive the ICT agenda. It was only really when departments came with major initiatives around that, and there was a lot of groundswell of support for that amongst all the professional associations, not just ICT-based ones, that it started to gain significant traction. And the same thing will happen with coding, and I expect it will take 10 years, just as ICT took that long.
Yeah.
But we see a gradual change. Cultural change is a slow thing. Yeah.
We're starting the journey, but it's got a long way to go before it's really embedded in.
And I'm really heartened by some of the things people have shared here at this conference in terms of the resources that are being developed and shared, and the teachers here who have shared their progress so far. And you guys are definitely an example of that, doing 3 presentations on the things that you're doing at your school, which is fabulous. And I think those stories shared and the resources that are being developed will really help others see the opportunities available. And there's so many examples, real world examples online of where systems and programs and apps that have been developed can trigger something within students, that real world application.
It is, and I think back to the session that Michael Henderson gave us, that wicked problem of how to drive this forward. And perhaps if we're honest about the things that we're playing with, the things that we don't know, and we do it in that playful environment of experimenting and having a go and sharing it, I think that's something that we can feel comfortable about moving forward, rather than trying to crystallize where we want to be and mandating. We
need to learn from some of the things we've learned around the ICT agenda. Some of the really strongest innovators are not necessarily the most effective at bringing the general teacher along.
Yes.
Because we're often doing things at the very cutting edge and very experimentally and very messily.
Yes.
While most teachers need a much simpler, stable, structured approach to doing activities.
They don't want to get as messy.
Well, messy can be fun and powerful, but it takes a level of confidence and acceptance of making a mistake and learning from the mistake as opposed to being threatened by it. Yeah. Certainly what we've done has been all by learning from other people's mistakes and looking at shared stuff.
Yeah. But also at the end of the day, you've got 26 kids and you've got an assessment item and you've got a report on it and all that sort of stuff. So sometimes that can constrict what you actually want to do.
Absolutely.
That's a good reality check. Thank you very much, Jason.
Yeah, but we still want to get that. We still want to get great ideas out. It's just not necessarily the way we do great ideas is often very experimentally. That's not what general teachers want. They want something that they know will work. Like the Beebot's been a great example of that. Scratch has been a great example of that. But Scratch at a sort of a normal level, not necessarily Scratch with Connect and a whole lot of other things attached on it, because that involves a level of experimentation and complexity that they may not be comfortable with initially. Hopefully, eventually, all teachers will get to there. You can always hope for that to occur. But the reality is that a huge number of teachers are going to be wanting some simple, effective material, like the C2C materials being developed and things of that nature, just to get started and have some worksheet type templates to work on until they can then get to a stage where they're developing their own ideas and resources and so forth.
You can't expect sophisticated ideas just to spontaneously generate. They have to evolve, and they often have to evolve from things that go wrong and things that don't work quite well and things that work really well but weren't addressing the syllabus. And it's an organic process, and that's going to take time.
I might ask for some questions from our audience here.
Peter, do you think the C2C units as being developed might prevent some of this repetition that you're worried about?
Well, only if there's a large variety of them. If there's a very limited variety of learning activities, then they're going to become the default templates. And everybody will do exactly that and nothing more than that, because if that's the only example they've seen, then that's the complexity they imagine is encompassed by what they're required to do. So the danger in an officially mediated repository of examples is that it's a torturous process to get things into it. And the time scale is often prohibitive, and the variety of things that have been stamped as approved often is limited. So they end up being very stilted examples and often done to death. Whereas I guess because we're part of the digital technologies community, we should be much better at sharing stuff.
Yeah.
And we're not. We are and we're not. We're our own worst enemies, I guess. But we've got to try and work out a mechanism that allows a broader contribution to the resource base, because if we're relying on the authorities only providing us with resources that are considered accredited and worthwhile doing, then my guess is we'll be waiting a long time to see the plethora of approaches and the richness of experiences. And
computing at school, the British website, like that's what that is. All the teachers just getting together and putting their own resources. That's a fantastic sort of thing. That's the sort of thing that we need here.
So possibly this is a major problem in the primary area, so feed about 6, 7 or 6. But as they gain confidence, then they can expand at the level rather than just do those templates and be locked into that.
It's tough being a primary school teacher.
Yes, it is.
My brother Joey was a primary school teacher. He was PE. He hadn't realised how much maths he had to relearn. He managed to mumble away of it, and now he had to actually teach it, and tortured himself going over other teachers' lesson plans and notes, and taught it badly the first time. But it was just a case of getting your legs and confidence, I think, as you put out too. That was something that now I'm reflecting on that is hard, and it isn't because primary teachers are slow at it. It's because we ask a hell of a lot out of them. They're really time poor. They don't have perhaps the spares that perhaps secondary teachers have to develop. They're meant to get it right first time, and there isn't so much intercollegial support perhaps for your specialty.
Well, the primary teacher issue is huge. It's an easily solved issue in terms of if resources put into some professional moment and they're shown some good examples, they can pick that up and they're not that complex. I'm more worried about the 9 and 10, 7, 8, 9, 10 levels, particularly with our ICT teachers transitioning to digital technologies. I think there's going to be a lot of resistance there where they'll still want to teach as ICT and not teach the digital technologies. I think that's, and also simply we don't have enough of them. Of course, not all schools will necessarily go for the 9 and 10 offering, but certainly for 7 and 8, there's not enough teachers at the moment for that to be a mandatory offering in all schools. So there's going to be a lack of teachers available, and you'll have teachers coming in from other areas and so forth without any real interest and capability in teaching computing. So I think there's a more intractable problem because the complexity of the concepts are much higher in terms of requirements in the curriculum. And some of those you really do need a reasonable background in IT to be able to actually explain and develop in students. The primary stuff's not necessarily at that level, while the secondary is.
Will school administrators be skilled enough to recognise teachers that don't have the skill set but still are allocated those classes because they need to fill timetable slots?
Because they only have who is tagged to teach a method subject, and for some of us that didn't actually make an appearance when we were doing a methodology.
Of course.
I've seen teachers who come into IT who transition from being the typing teacher or the commerce teacher or maths teacher or the woodwork teacher even here. Now we've got someone else here who wants to join us. And
I just thought.
Look, I've seen your toys at the front. I'm bringing my toy.
I think the toys aren't technical enough.
That looks like a bomb. Arrest him. Arrested.
Is it a clock?
I don't think it's a clock. I think it's actually
looks like a wearable.
It does look like a wearable bomb.
Now we were going to do a separate discussion with you, but the conversation was just heading to a really kind of logical segue. Oh, and I'm off screen now.
Off camera.
Thank you, audience technical assistant. We have a very high-tech setup behind the scenes here. Anyway, Joel is actually the final keynote at the conference, and he's been an IT professional working with teachers in schools, and it just seemed like a really logical moment when we're talking about, bringing in people who know IT and know what the real world is like to actually, bring you into the conversation. So do you want to? Yes, there's a real world outside of the school.
Yeah, well, I mean, I was interested in some of the comments that people have been making, and in particular in some of the questions. During the course of the conference, there's been questions about, for example, what resources are in place to support teachers to do this. Well, our program run by CSIRO, I'll put a little, unapologetic plug. CSIRO, scientists and mathematicians in schools and ICT in schools, get real-world industry professionals to come in and volunteer in the STEM subjects to help mentor teachers in new ideas. So irrespective of what the area is that the teacher is trying to cover, we have STEM professionals who would be happy to help at that level. There's many who want to help in primary schools. Exactly the sort of issue you were talking about. How do we skill up the primary school teachers? They're not confident. How do we get them to do these things? If they have a STEM professional, an ICT professional, who is there prepared to hold their hand, explain to them what's going on, that's exactly the sort of thing that they can do.
But we're talking about a capacity issue of hundreds of thousands.
I do understand that.
So
and
it's a
small
scale
steps. It's a scaling issue, and I do understand it's small steps, but it's something that we can add. There is no, like, it's a, going back to the original keynote, it's a wicked problem, and there are no one solution fits everything. So it's just a whole lot of small steps that we can make, and this is one of them. Talking about how do we get that in, one of our partnerships plays with these things. This thing I brought in, which was an Arduino for those non-techie people out there, and it's got some LED lights attached to it and a motion sensor that is hanging off the end there. And when something moves nearby, the lights flash. That's actually the basis of one of the projects that one of our ICT partners worked with the teacher that they're working with. Sarah Hobson, who's a member of QSITE, an art teacher, she'd heard about these things called Arduinos, didn't know what they were, wanted to include them in her art class, went to her IT partner and said, what are these things called Arduinos? And he went and researched them, found out what they were, because he was curious too. Explained to her how they work. They worked together up some little projects for the classes to do, and they came up with some brilliant activities for the students to do. So now Karsten, her partner, could go away and Sarah would have those skills with her forever.
Do we do that enough? Do we make those couplings with authentic scientists and engineers and mathematicians outside the classroom?
I mean, no, we don't. Okay. Australia is very bad at it. So I heard some statistics just the other day. The engagement of industry with research scientists, for example, which is sort of symptomatic of the same thing. Germany has 70% engagement.
Wow.
UK, which is sort of more from our background, 50%. Australia, less than 4% engagement between industry and research scientists. So, I mean, if that's how we're doing in industry and university, obviously we're not doing very well in schools. We do need to have that greater engagement between real-world science, engineering, maths, and what's going on.
It was interesting talking to you and realising you had a common research science background. My first exposure in schools was through the Royal Australian Chemical Institute, and I had a lab coat, and I would go to schools. I would boil cabbage leaves and make pH indicator and do some experiments. That was several orders of magnitude simpler than what I was modelling with the chemical synthesis in the lab. But the passion of actually showing what a real scientist did, and then actually being able to explain some complicated terms to some of the kids who ask questions and extending them and inspiring them.
It takes the pressure off a teacher to have to know all of that instantly or know the answers to all of the questions that arise, but and they can learn.
And you can begin to build on those discussions. It only has to happen once, but it does need an imperative on the school to permit some time in the curriculum to allow outside experts to come in, to take some steerage from the teacher, or to build some couplings like with CSIRO with your program. Now, you said it also embraces mathematics.
It is indeed, and we don't see, we're transitioning our program. Originally it's set up as scientists in schools, and it was Dr. Jim Peacock, the chief scientist at the time. His vision was that every single science teacher in every single classroom in Australia would have an scientist working with them. Of course, it never quite got there, but over the time gone, well, no, it's not just science, it's maths as well, and it's ICT, and it's engineering. So we really are sort of thinking of our program as more as a STEM professionals in schools. So, and it doesn't have to be the maths professional working with the maths teacher. What about the maths professional working with the science teacher? Because they might have some data, and the maths professional says, well, have you thought of analysing it this way? We've got the ICT professional can help with the science teacher. You want to do some data logging, why don't you get the kids to build their own data loggers using this sort of stuff here?
What you've got amazing amounts of data, what are you going to do with it?
Yeah. So it's the whole lot can come together, and rather than siloing everybody, we can bring it all together and have this real STEM across the curriculum sort of activity going.
Jason, will this become a new silo? It'll be
digital technologies.
Yes, the digital technology silo. So what?
Well, it's being defined as a subject. So yes, there is some siloing just by the definition of it as a subject. But as we know, there's a lot of capacity to utilise the skills and thinking approaches that they gain in digital technologies in their other subjects. Just as we could say from geography or history or mathematics, there's the capacity to use the things and ways that they learn to think in those subjects in other subjects. Siloing is more of an attitude of the teachers involved rather than the nature of the curriculum. But the structures of how we do secondary education support siloing, simply because we do break things into those. But there are good reasons for that, because we know in further education, it's now very, very difficult to get a broad enough understanding of a field to have a comprehensive understanding. The fields are continuously growing, and the nature of, say, in science is that you can't be a general scientist anymore and have a broad understanding of all areas of science. You have to specialise and build in-depth understanding. And that's one thing we don't necessarily do particularly well in Australian curriculum. While in England, with their 4 subjects, they get to go into those in greater depth in their senior years, we still have quite a broad education. So there is some advantage to building depth of understanding, but by the nature of that, you have to then focus and concentrate and leave out other areas. So the balance of that is complex. I think possibly we are a little bit broad in our overall curriculum, but that needs to be somewhat in place, because otherwise we wouldn't have digital technologies getting in.
The new Australian curriculum, don't you think that the flexibility that's built into that allows us to break down those barriers a little bit, make the borders between the silos a bit blurry, if I can mix my metaphors?
It gives the possibility, but there was actually a fair bit of disappointment in ACARA, in that it was set up, of course, the political decisions at the time, particularly around history, siloing and structuring things as subjects. There was a movement to have no subjects, to have learning approaches and so forth. And at one stage, even as the general capabilities, as like the subjects, with all the, what we now know as subjects, being the context for a much more integrated curriculum approach. But that's quite complex and probably too dangerous for a national curriculum approach.
A step too far.
Well, to get agreement on that would have been a very, very ambitious approach.
But if a school chose to
that's
things up a bit more,
it's possible, but the nature of how the curriculum has been developed now actually has inhibited that. We were going down that pathway. In Queensland, we had a very innovative approach where we were having schools doing 4 thematic units, fully integrated for their curriculum across the various years. They built an assessment model around that was too expensive because it had whole lot of cost moderation. But that was an attempt to do an integrated curriculum approach. Whether or not that approach would be possible or supported within the Australian curriculum structure now, I probably have more doubts.
It would probably take more than a political term to implement that change, so that makes it really difficult as well.
It would, and well, it was lucky that they had the Director General of Education in Queensland that went on to become then the developer of that model, and so they had a whole lot of forces aligned to allow it to occur in the education system at that time. But then with a change of politics and change of funding for the initiative, it was dropped.
Can I ask a question, Joel? Will this stimulate innovation and creativity?
I think this is brilliant at doing exactly that. You have a thing like a code club or a maker space or something like that. It does. The kids try things, they experiment. And if you've got a teacher who's not confident in that, and they've got a professional coming in and just giving them that support to try something new, do something different. They bring in an idea from work or from their past experience, And the teacher goes, well, if that's what they're doing out there, maybe I should try and do it in here. Let's do something different. I think
as long as the emphasis is on building the capacity of the teacher to in future try new things, and not the teacher relying upon the external expert as a substitute for their own.
Well, and that's the whole program is mentoring the teachers, not mentoring the students. And that's a lot of the professionals who come in, the last thing in the world they want to do is face students.
Or build a dependency that's not in the long term a healthy relationship.
That's right.
Now, I notice it's pretty much lunchtime here, and we said, 10, 15 minutes, and we've probably been talking a bit longer. And you do have a keynote to get to as well. So we might just quickly sum up. Roland, did you want to do your grand if statement?
If we could build the spaces and the places, we could drive change. But I'm savvy now that it'll have to build capacity in the teachers to deliver this. It will have to develop the connections with outside groups, professionals who can help advise. And I'm reminded of the coaching role that teachers are having to work through. But if we could do this, then we will have children who can help build the nursing homes that will take care of me when I need them.
The robots that will take care of me.
Yes.
It'll be a better world. And I'm engaged by it.
Program to care.
Yes.
Thank you. Tim.
Yeah. Well, I'm really excited about this new curriculum, and I'm lucky that I'm working in a place that allows me to experiment and will support me and buy this sort of stuff for me, because it is expensive, end of the day. And we've been a little bit ahead of this, and so I'm very happy and pleased the way that it's going. Not sure that answered the question, but
it's good enough.
Peter.
I'm fully supportive of the whole nation. I like the idea of trying and succeeding sometimes, failing other times, and being relaxed enough to do that. And digital technologies context is a breath of fresh air and a formalization of a puddle that we've been really passionate about, but really haven't had any label to categorize their activities under. So
you've moved from a puddle to a pool of learning.
Yeah, or maybe a stream.
Or a beach.
Probably a waterfall.
Yeah. Or the gene pool, Jason.
That was a painless segue. That was.
I'm very confident and positive about the progression we've reached to this stage, but I see it still only at the very first step in a long journey.
Yeah.
And there's many different hurdles we still need to overcome, particularly broadening it for others to be included within the passions that we all have for the advantages of digital technologies and what can give to students. I think there's lots of forces that are supporting us, but I think there'll be a lot of forces also that will try to oppose change, and we need to be mindful of those and help overcome those as we progress.
Thank you, Jason. Joel.
Well, I think I'm positive. We look forward to some really great change coming, and I think that if we grasp it, then we can achieve things.
Yeah. I guess my reflection is based on the first keynote as well, that idea of what if we found some answers and understood our wicked problem of implementing the digital tech curriculum. It could be really exciting.
Thank you very much for listening, everyone, and I hope you enjoyed it. And looking forward to your keynote, Joel, and we'll be posting up some links at the end. I hope you've enjoyed this series, and stay tuned for ACCE 2016, if.
Yay.
Not if, it will happen.